My name's Craig Dunn, for those of you who haven't met me yet. I'm a developer at Xamarin, a developer evangelist, I should say. And today we're going to talk about your first XamarinForms app. So by the end of this session, I really just want you to have some familiarity with XamarinForms, the concepts behind it, and to have seen apps being built so that you can literally walk out of the session here, go upstairs to the Darwin Lounge, and do the XamarinForms hack, which is building your first app. So before I start, forget everything that you know about building mobile user interfaces, because XamarinForms is something slightly different to what you're used to. There's a whole new set of controls that enable you to build a user interface that runs across all three platforms, but in a native fashion. So the first thing you need to know about are pages. And XamarinForms apps are comprised of pages which take up the screen. And the most important one of those is a content page. So this guy is going to be your friend for all of your XamarinForms development. It's a container that you'll put all sorts of stuff in that will render on iOS and on Windows and Phone and on Android within whatever native user interface idioms you want to create within it. And there's a few other page types as well. Master detail page, navigation page, tabbed page, and a carousel that will let you compose different content pages to build your user interface and allow your users to navigate between them. Now, not all of those idioms are common to all of the platforms, but XamarinForms uplifts the platforms that they're missing so that you can build it once and just assume that it's going to run and be presented natively on iOS, Android, and Windows Phone. To get something into a page, you need to lay it out. So we have layouts. And the easiest one to kind of comprehend is the stack layout. So if you're a Windows Phone developer or any XAML developer, really, you're already familiar with it. If you're an Android developer, you're familiar with the concept of just stacking a whole pile of controls, one on top of the other. No XY coordinates, no width or height to worry about. Just stack them all on the screen and let the layout engine worry about how to represent them. And this is a really quick and easy way to get started building XamarinForms layouts because you can just whack all the controls on the screen. But we have other more complex layouts as well, so that you can represent things with an absolute positioning system. You can lay them out relative to each other so that things size more nicely as your application runs on small screens and big screens and tablets. We have grid layout, a content view which you can use to create user controls that really nest all sorts of different things. The scroll view, as you would expect, and a frame which you can use to create sections within a screen. So there's a number of layouts that you can put inside a content page which you can nest inside the other page types. So with these set of controls, you create the navigation system and the hierarchy of your application. We also have some controls that you use to compose your user interface. So the ones that you expect are all there: button, entry, image and label, and list view, and the map and web view. But there's also the secondary set that you obviously want to use occasionally, like activity indicators, this Boolean switch, and so on. So there's 40 controls that you can compose in a layout, put in a page, and render on the screen. So this is a simple XamarinForms page in C#. If you look at the very top, I hope everyone can see the screen and read it. It's a class that inherits from content page. So this is the way you use page by implementing it. In the constructor, we're going to set up our layout. So we've created a button. A button object is just an object, so we new it up. We want to set the text on the button, so we do that. And because the button has a clicked event, we can assign a handler to that, which is declared at the bottom of the class. So once we have a button, what do we do with it again? Oh, we put it inside a layout. So then we create a stack layout. And because the button is going to be lonely otherwise, I'm just newing up a label directly into the stack layout, and then I'm assigning that to the content of the page. So here's the first new thing. Pages have a content property. Content is one of the layouts or one of the view types. So there's only one. So you could put one button in there, or you can put a layout that then can contain multiple things. So content page has content, which is a single element, and then that element needs to be a container for whatever else you want to put on the page, and it can be a layout of one of those different styles: stack, grid, absolute or relative. And that's all that you need to do to express this page in Xamarin.Forms. And we can load that up and run that on a screen, and it'll render in iOS, Android, and Windows Phone with a button and a text label, just like you'd expect. But the other thing Xamarin.Forms brings to mobile development for iOS and Android is XAML. So Windows Phone and WPF and Silverlight developers already know about this. But you can represent markup declaratively. And the code on the right is actually two files, the XAML file at the top and the code behind at the bottom, that represents the same thing as the C# on the left. So if you're familiar with WPF and Silverlight and Windows Phone, that XAML should look familiar. There's a content page on the outside that contains a layout, stack layout, that contains two controls, and all of the properties are set declaratively. In the code, we don't actually have to write anything to do with the layout. We just create a clicked handler, which we've defined in the onClick event in the XAML. So two ways of doing exactly the same thing. Now, the one thing that's important to remember is that our XAML is not Microsoft's XAML. XAML is a markup language, like definition. It describes how we use XML to describe an object graph. But our objects are not Silverlight's objects. So you can't use the visual designer in Visual Studio to edit Xamarin.Forms XAML, unfortunately. So let's move on. This is where we're going to build our first Xamarin.Forms app. But we're not going to do just that label and button, because that's way too simple. We're going to add an array into it. And because I've got a picture of a pool table playing monkey, it's going to be 8-ball themed application. So we're going to start from File New Project, do a screen, add some code, and then look how it runs on all three platforms. Let's stay there and switch into Xamarin Studio. So from Xamarin Studio, am I still on? Yeah. We'll look for the mobile apps and choose portable. I like portable better.
Everybody seems to like portable better.
Yep, and actually I will talk a bit later about maybe when you would choose the other one, but for me, it's a simpler way of working. So we've got now a beach ball. We have a Xamarin.Forms application. Now I've created in Xamarin Studio, so it's created for us automatically an iOS and an Android application, as well as the PCL library. We're going to do all our work in the PCL library because Xamarin.Forms code is always shared. But we need an Android library and an iOS library as like the container for the Xamarin.Forms application to take it onto that platform. So let's start by adding our page. So we're going to add a new file, and we need to change this up to forms, and we'll select a content page, magic ball. So it's created the same sort of thing that you would have expected in Microsoft World with any XAML. It's created an XAML file here and a code behind. So as I said, stack layout is going to be our container. We're going to have a label with some text. Let's say that'll be 8. A button needs some text, and a clicked handler equals, let's call that shake clicked. Oops. So actually, I apologize for having small code. And let's have another label called X. So what am I doing now? X name equals. So elements on the XAML page, if you want to refer to them in code, need an identifier, the variable name if you were developing in C#. So we've got a simple label. Actually, let's bump up the font size on that. A button with an event handler, an output. And we don't need to give the button a name because it's just going to use whatever event handler we define. But we need to give the label a name so that we can actually set its text value from code. So here we have a screen that we can run on iOS, Android, and Windows Phone. Back here in the user interface, I need to create a handler. So void, what do I call it? Shake, clicked, object, sender, event args, e. What's this button going to do? So what we're going to do is a magic 8-ball. It's going to tell me if this presentation is going to go well or not. So let's add the implementation for our random equals new system random. And then output. So that output.text is the UI element in XAML. We'll set that to options, random next. Length. Autocomplete in a big font size is really weird. -1. And I think that red is misleading. So we're waiting for the build at the top. No, let's not wait for the build. So here's one I prepared earlier. So this is the app running in the Apple iOS simulator. I actually substituted the text at the top for emoticon. So if I press the shake button, it sets the response onto the form. And if I open the Android player, oh my goodness, thank you for the Android player. If anyone was with me during the last 2 days in the training sessions using the actual Android emulator, gosh. So the emoticon is rendered slightly differently, thank you Google. And the shake button, oh, it seems to have fallen asleep. Oh, anyway, for now you can see that the rendering is slightly different because it's a Google button with a border around it and the Google font, so the emulator that shows in a different emoticon representation than this guy. And if we go over to Windows Phone, didn't bother with the emoticon here, but it looks different again because the shake button is that boxy thing that Windows devices use. So if I press it, it will keep telling me it's not sure how well the presentation is going to go. But you can see, actually I can line these up for us. You can see that's Xamarin.Forms. So we wrote the user interface once, a couple of lines of code to represent an object graph that we want the user to see. But it looks very different on all 3 platforms because it's using the native controls and the native elements. So this is one of the reasons why XAML makes sense for Xamarin.Forms and the layouts that we've provided, because X, Y, width, height, coordinates do not make a lot of sense when you're trying to lay out in this environment. You need to think of the user interface conceptually and that you're building an object graph or a visual tree for people to look at. But it will be rendered differently for each platform. And times that by another grid when you're thinking about tablet devices for iPhone and for Android as well. So that's our first XamarinForms application. We didn't dwell a lot on the details because we're going to talk about them in more detail when I can see PowerPoint. There we go. Back to play. So traditional Xamarin development we've often used this slide to represent it. You can write shared C# code, which is your business logic and your user interface and your database and web services and so on. And that's this big blue box that you only have to write once. And then you build native UIs. So you build a purple box, a green box, and a blue box. And that stuff is UIKit, or it's Android views, or it's XAML on Windows Phone. And in each of those, you tweak and twiddle those user interfaces to make them look nice, and you get the benefit of native performance. But you can only share 60 to 80% of your code. And those are the figures that our customers tell us from their applications. But using Xamarin.Forms, you push up what you can share to include most of the user interface. So as you just saw, we can build buttons and labels, we can have scrolling list views, we can represent the web view and maps using one user interface definition. So in a blank Xamarin.Forms app where you just add code in forms, the purple, green, and blue box is 2 lines of bootstrapping code. So that's the application-specific projects that just surface Xamarin.Forms on each platform. So you use the same strategy for business logic and web services, and you build the UI in Xamarin.Forms and share that as well. And now you're suddenly sharing 99% of the code because you don't have to write anything platform-specific. But that doesn't mean you can't. And once you've got a working Xamarin.Forms app using pure Xamarin.Forms, you can extend the purple and the blue and the green boxes all together or just focus on one using platform-specific enhancements, using dependency service, custom renderers, and a few other techniques. We'll touch a little bit more on them today, but Jason's talk later in the week will cover that stuff in detail about how to extend Xamarin.Forms to fill in native UI within the Xamarin.Forms framework. So you get the benefits. It's a native look and feel. Your customers realize it's a Windows Phone button or a scrolling Android view, but you get the code sharing and reuse from building it once and testing it once. While, as I just said, using custom renderers and dependency service to access camera, accelerometer, GPS on all the devices, or NFC, PassKit, HealthKit, any of the new iOS 8 stuff, or Android L on each different platform. So now I want to talk in a little bit more detail about how Xamarin.Forms actually works. So we just built an application, and we did it really quickly and didn't really discuss the moving parts. And I want to look more closely at the anatomy of the solution itself, and then talk about how controls, layouts, and pages fit together. So firstly, when you create a file new project for Xamarin.Forms, you have to choose between PCL or shared. And I mentioned earlier that PCL is my preference. And the key reason for that is it supports refactoring in an obvious way. And it forces you to manage your code if you can't accidentally put platform-specific code in a PCL and then wonder why you broke something later. So it's a way of enforcing strict practice about what code can be shared and what code needs to go in a platform-specific project. But shared projects have their place. A shared project lets you use compiler directives, if iOS, else Android, to mix and match code inside the shared code, which can be really powerful when you want to add libraries that don't have a PCL representation. And I talked this week about Salesforce and parse libraries, both of which work well in the shared project environment. But it kind of breaks refactoring because you can only refactor one of your projects at a time. So it's something to be aware of. When you refactor one of your projects, you're going to change code, then the other one won't compile until you go and manually sync it up. So it's a matter of understanding the pros and cons of each. But for starting Xamarin.Forms, I would suggest PCL is a good place to start. Xamarin.Forms itself is shipped as a NuGet package. So if you haven't used NuGet before because you've been a Xamarin developer and we've sold you on the Xamarin Component Store, you need to be familiar with NuGet as well. And we've added support for that in Xamarin Studio. It's been in Visual Studio for a long time. And the template will automatically have a reference to the NuGet projects. So when we did file new earlier, it was automatically downloading the NuGet package so that the application would start up. Xamarin.Forms does not automatically pull down the latest NuGet package. And this is a common thing for people that are starting with Xamarin.Forms and then coming to our forums and not understanding why one of the newer features isn't working. So it's good practice when, if you can see in that very tiny screenshot next to Xamarin.Forms, there's a grey version number. And the idea is giving you a hint that there is a new version. Do right-click and update on the packages directory to make sure you've got the latest version. The next thing is the app.cs file. And we kind of skipped over this in the demo. But this is the starting point for your Xamarin.Forms application. In the shared code, there's an app.cs that returns the root page for your application. And so this is where you add the starting point for your application, delete the boilerplate that we provide, and start your application from there. And it also can be a good place to store other platform services that you want to share, and a place to register for databases and other stuff that you're going to dependency inject. And we'll look at that at the very end. Then we have 3 platform-specific projects. If you create in Xamarin Studio, we will only do iOS and Android. If you create in Visual Studio, we'll create iOS, Android, and Windows Phone. And like I said, you don't need to do any code in these. They're really a container that surfaces the Xamarin.Forms code onto the platform. But you still need to do some stuff, because the platform-specific libraries are where you set the application icon, the name of the application that appears on the start screen of whatever device that you're using. There's various, like the bundle ID on iOS, or the application code on Android. So you still need to do some configuration in this project to get the application looking nice, setting the application icons and so on. And like I said, you can extend the application with native code, and we'll look at that a bit later. The iOS app is the same deal. You need to put splash screens in the resources directory to make the app scale up for the new phone sizes, because otherwise it'll be a little letterbox fat thing. You need to set the build properties in the in the properties, so that it has the correct bundle ID, it matches your provisioning file. Anyone that's done iOS development is nodding now, oh yeah, that's a pain. So you have to remember to set that in the application-specific project for iOS. And for Windows, we have Visual Studio providing its own representation of the tree. And you have to do the same thing there. Set the application tiles, the opening images that you need to support, so the application looks nice for Windows Phone users. And what about controls? We touched on this a little bit already. I'm going to walk through it again. How do controls fit together in Xamarin.Forms? And I've drawn just a prototype there with Balsamic to talk about it, partly because, as we saw at the start, it's hard to draw a Xamarin.Forms screen in any particular UI, because it might look very different in one of the other UIs. So here's what something we could build in Xamarin.Forms, the button and the text, and we saw it earlier. Hello world. Is everyone familiar with the object initialization syntax? To some people, this looks new. Hello, new label. And there's no parens like you normally put at the end of the constructor. Instead, I'm just starting with a curly brace and setting properties of that object. It's just a C# shorthand, but we're using it a lot now in Xamarin.Forms code examples, because it's a really quick way of instantiating and setting properties on user interface objects. And it kind of looks a little bit like the XAML when you do it that way. So you'll see that a lot in our code samples. And then we've got a button that we've newed up. We've talked about that before. And then we looked at the clicked event. We've added an async event handler. So async is no problem. You can embed async await code in your shared code and make sure that your Xamarin.Forms app remains responsive when you're doing network operations. But as we said earlier, then where do we go with these two buttons, this button and this label? How do we lay them out? So that was where the stack layout came in. And I made light of it earlier and said we just throw them in and they just all lay out. But there is more to it than that. So at the top, in addition to setting the children, we can set the orientation of the stack layout. So the default one is vertical, so it's easy to use. But you can lay out horizontally as well, so that you can use it for a label and an entry. And the same thing in XAML. And there's other properties as well. So we're only touching on the very tip of the iceberg in this session, because you've got a whole week of sessions to learn. But there's padding available so that you can use that to make some room around the controls. And so we've got the controls and we've wrapped them in a layout, and then we need to wrap them in a page. So the code gets slightly bigger. We implement the clicked handler, so that is always going to live in the code behind. And we've got a working application. It's very similar to the 8-ball that we saw with just a few lines of code. So I've drawn another mock-up here. How does that representation that you make of your user interface get onto all three platforms and be native? Like, what's the magic behind that? So imagine that you've got that design. Let's stay with it for a minute. Imagine you've got that design and you're not a programmer at all. So you have 3 friends that can develop for iOS, Android, and Windows Phone. And you call them up one by one. And the guy that knows iOS, you tell him, I want a tab control. And then in the tab control, I want you to put a label and an image and then another label. It's going to look like that, which is a perfectly valid and native representation of what you just described on iOS. But when you call your mate that does Android development, the tabs are going to be at the top, and the font is going to be all caps, and the labels and text and images will appear. So it's already different, but it's the same Xamarin.Forms. It's the same user interface rendered with native controls. And when you call the Windows Phone guy, his tabs are huge, and they're all lowercase. And you have to slide along to see the whole set. But it's still the same user interface. So these are the challenges that you have when you're thinking about building a user interface with Xamarin.Forms. You're representing concepts in the code and in the XAML, and they're rendering differently on each platform. And that's kind of what you have to embrace, because ultimately your users are going to be much happier on Windows Phone seeing those scrolly tabs than if you tried to put 4 square buttons along the bottom. And that's the power that Xamarin.Forms gives you. But Xamarin.Forms does more than that, because not all user interface idioms are available on all the platforms, particularly some of the popular ones. So master detail page is really only natively available on Android now with the navigation drawer. But it's hugely popular way for people to build master detail relationships or menus with submenus. So we made it available on iOS and Windows Phone. So we give you a single way to build a master detail just with 2 content pages, or with a content page and then a collection of them. And then on iOS, on the phone form factor, Xamarin.Forms provides you with the swiping UI, the show and hide for the master. And then when the user scales up to an iPad, we use the built-in UI split view controller. So we're always taking advantage of the native controls whenever we can. Android, we just use the native control. And on Windows Phone, we had to think of something fancy, because Windows developers aren't familiar with swiping in from the side and seeing something revealed like that. So we implemented it as a button on the app bar, and when they press that, the master will appear and disappear. But you don't have to worry about that, because you implement one navigation page, and we render it for you, whatever is appropriate for the need for the user on their device. And the same with navigation page. This is a bit more common. Everyone's familiar with click on something to go forward and hitting some sort of back thing to go back. But our navigation page uses your navigation controller on iOS. So you get the familiar behavior with swiping and the back button inheriting the name of the previous titled screen. On Android, we use the hardware back button, obviously. But we keep track of the stack for you so that you can push back to the beginning, or you can push through and back individual pages. And the same for Windows Phone. Take advantage of the hardware back button and the built-in back stack so that it looks familiar to Windows developers. But in your Xamarin.Forms code, you're doing the same push to a new screen. There's no creating intents, no setting up an activity or anything like that. Simple common interface using the content page class that you can use across all 3 platforms. And as you all heard this morning, in addition to the controls that we provide, there's 140 new controls on the way for Xamarin.Forms. So Sync Fusion and Telerik controls are available, and the Steamer Component 1, DevExpress, and Infragistics controls will all be out by Christmas. So in addition to the set that we already discussed and the set that Nat mentioned that the community is contributing, there's a whole set of commercially available controls that will become available to you. And you might have already used the non-XamarinForms versions of these in your native apps, or you might have been using them in Windows and ASP.NET before. But this is going to bring a very large variety of new choices for representing your data and user interface with XamarinForms. So let's look at our second XamarinForms app. And we're going to look at, we're not actually going to do file new, I lied. But we're going to look at the to-do app and examine all of these things that we've just talked about in the concept of a slightly more complex application, so that we can discuss the features of XamarinForms and how they interact. So here we have the to-do version of XamarinForms. And let's start with the solution. So as I mentioned, we have the PCL with shared code. And within that, I've created some content pages, a data model, and a database class, which we'll look at in a minute. But it's 3 simple pages bootstrapped by the app class. So let's look at what the app class is doing. The first thing it's doing is creating a navigation page, which was one of those other page types that we talked about. And we're setting the first element of that page to a list of to-do items. So let's follow the tree further down to the to-do list page. And this is how we set up. I'm trying to get that bigger. It's not working. That'll do. This is how we set up a list view in XamarinForms. So we're creating an instance of the list view control in the first line. And then we need to determine what to put in the cell of each list item. And there's some built-in classes, but I've built a custom one, so we're going to look at that in a minute. But it's called a data template because it's going to get reused. We're going to put different values in it as it scrolls. Then we're going to set the item selected event so that when the user touches on something, we can view it on another screen. And within that, we'll see our first touch of the navigation class. So the navigation class is, well, it's a property on the page that will let us just easily push to a new page, which is going to replace the current page on the screen. We can pop to go back so that we can easily create a walkthrough navigation like you're familiar with in the existing platforms. We scroll down, and we're creating a new stack layout for this page as the container. It only has one child, the list view, on most platforms. But you can also see here, even within the shared code, I can make decisions about specific platforms and tweak what I want to show. So on Windows Phone, I didn't get a big to-do box at the top like Windows users often expect. Big font heading for the page. So I added it manually by adding a new label to the stack layout I created and setting the font to this large size. So for iOS and Android, that's not going to happen because we can determine the device platform and optionally add elements to the user interface. And then we're setting the content property. So like I said, the content property is a single property that you assign a layout or some element to. So that's going to display a list view, optionally on Windows Phone, add a title to the top of the screen. But when is the data coming in? Now, you would have a lifecycle event if you were building something in iOS or Android or Windows Phone. You wouldn't be putting the data in on the constructor because when someone comes back to the page, the data might have changed. So Xamarin.Forms exposes lifecycle events on appearing and on disappearing. And so for now, I'm overriding on appearing, calling base to make sure that the functionality flows down, and then calling this database get items. And we can worry about that later, but that's actually the same code you would write in any Xamarin.Forms app. And setting the item source for the list view. So now in the constructor, we're setting up a user interface and adding elements to it. And then every time the screen appears, we're going to update the data to make sure we pick up latest changes that someone's made. So we skipped over the creation of the item cell. So let's have a look at that. Item cell is a custom view. So you can think of it like you do any custom view on the platforms you're familiar with. It's just a smaller view that you can use to lay out objects. So we inherit from view cell, and then we just build up the user interface the same way that we did with the content page. So we new up objects like labels, an image, which is going to be a check. This is a to-do app after all. And then we're going to create the layout. Now there's a lot of new properties being set here. The padding is being set on the layout. So at the very top of this layout, we're going to come down 20 pixels. And it's a bit of a hack, but it's pulling us down below the status bar on iOS. And there's many other ways to manage that as well. But for a simple example, you can add padding to the left and the right and the top and the bottom of your view so that it has space around it to help you with your layouts. And we've set the orientation as well. Because it's a cell, we want to switch from the default stack layout to a horizontal layout so that the tick is next to the label, not underneath it. And finally, we've set horizontal options to start and expand. So when you're dealing with layouts like this, where you're not specifying X and Y and width and height, you need a way to describe this thing should go the full width, or this thing should just all sit to the left or sit to the right. So we have layout options that you can set: center, center and expand, end, end and expand. So center, and then fill and start. So start is to the left for a horizontal layout, or it's the top for a vertical layout. And similarly, end is to the right or to the bottom. So you can specify these things in your C# or in the XAML if you're using XAML. So if we just run the application from that point, there we go. This is the to-do item list view screen that we just built. So it's pre-populated data from the database, which we'll talk about setup in a minute. But within the list, we have cells that I defined as a text label with an image next to it. So that works fine, that's familiar. And then when we click on it, it's showing a new screen. And we'll look at that in a bit more detail too. But it's that easy. I mean, that's a lot easier, I'm sure iOS developers will agree, than creating a UI table view source. And it's also easier than creating an adapter on Android and implementing get cell and implementing the row selected and that sort of thing, and having to do it on all three platforms. So let's come back to the code and look at the things we skipped. So in the list page, we did these two things. We newed up the next page that we're going to show. And then we set the binding context on that page to some class. And the class is actually the item that was selected. So it's a to-do item that's come from the database. So we're setting the to-do item that the person clicked on to the binding context for the next page we're going to show. And that means that next page is going to have access to all of the properties of that class through the binding infrastructure. And that just makes it a much easier way to display data and get data back from the user. And we'll have a look at the implementation. And then the second thing we've done is use the navigation property to push the next page onto the stack. So to display a new screen, we just new up the content page. We can optionally set some properties on it, either our custom properties or set the binding context, and then push. And on each platform, that old page will be animated away and the new page will be animated in what is appropriate for that platform. So what's happening on the next page with the binding context? So here's the page here. It implements content page, like all of your custom pages will, or some subclass of it. And we're using set binding calls. So the content page has a title, which is the text at the top of the thing on iOS in different places on different platforms. And we're assuming by using that method, set binding, that a binding context exists. So we've set that binding context in the previous screen, and now all of the properties of that object are available to us here. So this page's title is going to be set to the name of the object we put in the binding context. So this is old news to Windows developers, and it's maybe new news if you're from iOS or Android land. But you can apply that throughout the form. So we're newing up labels throughout this page, and we're binding and inputs, and we're binding the content of those things to the object that was passed through. So we're setting the name property of the object of our to-do item. We're putting that in an entry. We're putting the notes property of that object into another entry. And we're setting the isToggled property of a switch, which is a Boolean, to the Dunn property of our to-do item, because that's a Boolean, so that types match. So what that allows us to do is not only, when we set the binding context, just render that stuff in the XAML or in the C# user interface when it's rendered, but when the user is changing those things, the binding is updating the object. So when we get to the Save button down here, we're not querying the user interface. What is the value of entry 1? What is the value of entry 2? And copying that stuff out. We merely need to get a copy of the binding context. We need to get the binding context. And we can save that object to the database. So using data binding, either via C# or declaratively in XAML, lets us get a whole lot of work done without copying data around. And because the user interface is Xamarin.Forms, it's happening on all three platforms. And after the save item, we're again using the navigation property to push back to the list screen. So we've saved the data to the database. We'll pop back to the previous screen. And we know, because we're using the lifecycle event on appearing, when we get back to the list on the previous screen, the item that we've added is already going to be there. So if we just jump into the application, we can add new task, set the property, and that stuff's just, the binding system is putting that data and the state of the switch directly into the class, so that when we hit save, it just gets pushed straight back to the database. So with very little code, it's easy to create input forms like this that are going to render across all three platforms. So it's going to be a really fast way to build out data input scenarios and applications that require like navigation and user interaction. So we've looked at some of the simple stuff, but how is the database wired in? because as I mentioned, you can do that in Xamarin already. You can get SQLite running for iOS and for Android, no problem. And you can share the code that uses it. But how does that work with XamarinForms? Because you can't put all the database setup in SQLite, in the XamarinForms shared project. So what we do is use the concept of coding to an interface. So if we look at the database class itself, we've got methods for get items not done. So the general CRUD methods that you're used to seeing, get, delete, update. But they're referring to an object which we're getting from somewhere else. So XamarinForms provides a dependency service that lets you pull stuff in from the native level, from the native applications. So interfaces are the glue that pull those two things together. So we have in our shared project an iSQLite interface. It's just got one method, get connection, get me a SQLite connection that's valid for the native platform I'm running on. And then in the database code, we use a dependency service to call that method. Dependency service.get, find me some implementer of this interface and call the method on it that's defined. And the code is going to get a SQLite reference. And from there, it's no problem to save, update, delete. You can see create table is being called, and save and query and other methods that you'll already be familiar with. So how does that work for the platforms? iOS we'll start with, and we'll look for this implementation of the iSQLite interface. So this is the way that you can pull down a lot of platform-specific functionality into your XamarinForms app while still taking advantage of having the same user interface code. So we've got a SQLite connection, and this code just comes from an existing Xamarin iOS application. The main reason it needs to be here is because we're looking for a folder path, and the file systems are different on each platform. So we need to pull this up into the native application. But we return the connection we've created from SQLite, and the XamarinForms code doesn't care that that stuff came from a native platform. So on Android, we've done the same implementation of the interface. We've implemented the different file system stuff that's required. And XamarinForms doesn't care. It gets a valid connection, a valid Android SQLite connection, and then loading and saving is a breeze. So we've defined those implementers of the interface in iOS and Android and Windows Phone projects. But the PCL doesn't actually know about those, so then how do we link them together? How do we tell the PCL, yes, I've implemented it, look here for this implementation? That is an assembly attribute that we use called the dependency. So you're registering that, yes, XamarinForms application, when you're running, hands up, I've implemented the interface that you're after in this class. So if we deleted that, it would be unable to resolve and the application's going to crash. So there's a few steps to getting the dependency service working. You do the interface in the shared code and code to it. You implement it in the applications, and then you add the assembly attribute, which is the hands up, I've done it, and you can find it here. And you can do all sorts of stuff with the dependency service. So SQLite is a very useful one. Most applications, I'm guessing, are going to want to do that. But we also implemented text-to-speech the same way, so the application can actually read out values from the app. And it's a common thing that maybe you want to do, and it's fairly simple method, I just want to speak some text. But it's obviously platform-specific implementation, so we can build it for iOS and for Android and for Windows Phone and surface it with the dependency service. While in the application, the shared code itself, just using a simple interface to code against. And if we find the speak button, there it is. That's how you call a service that you've defined in your native apps. Dependency service.get, it's a generic method. You tell it the type you're after, And that's cool because that means that it can autocomplete the methods that are on there for you to choose from. So working in this way gives you an easy access to lots and lots of API level features in native platforms. If it's not available in all the platforms, if you want a dependency service something that's not in Windows Phone, for example, you better use that code we saw earlier to wrap the call around the dependency service. Only look for a reference for an implementor if you're on a platform you know implements it.
Sorry, I'm not sure what you said.
Oh, did she come into my talk? Cool. That was a very fun part of the keynote, I thought. So you can bring down lots of platform-specific functionality from Windows and iOS and Android using the dependency service. And there's not a lot more code complexity in your application, especially when you compare it to if you were building this thing 3 times, right? So there's not much more to this application, the to-do list. It's got a database, which we saw how it gets pulled in. It's pretty simple CRUD methods. It's got a couple of screens, which we've newed up using the same controls we're already familiar with. And it's got 2 native features pulled down, the database itself and the text-to-speech functionality. So if I was writing this from scratch, which I would have maybe been bold enough to try, but demo never work out that well, it would have only taken me half an hour probably to code it from go to woe, because there's so few lines of code. And of the code there is, it's going across 3 platforms, so let's divide the time by 3 and call it good. And this is going to be a really fast and easy way for you to get started with mobile application development in general, with cross-platform applications specifically, and start to get a feel for how you want to build your apps across all 3 platforms. So let's close out of that. Just quickly, while we're here on the Windows Phone, I had a bit of a resolution fail here with Visual Studio. I'm loath to change it for fear of screwing it up. But just to show you, the structure in Windows is exactly the same. So we have a portable library in Visual Studio with the app class, with that 1 line of code, create up a new page, the XAML, and the XAML code behind. All looks and works just the same way as Xamarin Studio. And then, obviously, as well as the iOS and Android projects, the Windows Phone project as well. So let's get back to the slides. So this is the dependency service we looked at, and I just did a breakout of the code to make it clearer. That create an interface in the common code, and then code against it. And then in the platform-specific code, write an implementation. It can be as complex or as simple as a 1-line file system return, or multiple lines of setup or configuration and access to native APIs. And then use the dependency attribute on the assembly to raise your hand and say to the code, this is where to find the implementer of this. And there's another trick for dependency service that's going to be useful for when you're building stuff on Android. And that is that XamarinForms on Android provides a context property. So you can do forms.context, and it'll be the context, the current Android context that your code is running in. And if you're familiar with the Android API, lots of methods require context to call. So the text-to-speech example is a good one, that it uses forms.context to enable us to actually start up the text-to-speech service on Android. Because otherwise, you're in XamarinForms, you don't really know necessarily what's going on around you, but you need access to that context. And so XamarinForms provides it to enable this sort of extensibility. So we also looked a little bit at data binding. And I showed you the code version where you do .setBinding, the property, the thing you want to be the target, and then the name of the property on your object that you want to show. So that's really simple. I think people that are familiar with XAML already know the much easier and simpler syntax is curly braces. So if you want to set the text of something, it's curly brace, binding, and then the property. So it's super easy to get used to. Just rather than right to left assignments all through your code, use binding context and data binding either in C# or XAML to surface values and get changes really simply without lots of code. We also support the command pattern so that you can create view models that can provide functionality as well without being tightly bound to the user interface. XamarinForms also provides a messaging center, and it's designed to be a simple and easy to use way to send loosely coupled messages between parts of your application. And if you look at the XamarinForms version of the Evolve app, which I believe we're going to try and make public, but other samples we have as well, we use this to communicate between the master and the detail page in the master detail view. But you can use it in many other situations where you've got multiple things happening in your app, and you may or may not be able to handle them, depending on what screen is displaying. So subscribers might be something happening in your application, can register for a particular event. Let me know if this happens, and while I'm in memory, while I'm active, I'll get a callback about it. And then I'll define what that callback handler is. And publishers, could be another screen, could be a button, could be a download finished event, could be anything, will send a message to the messaging center, who will then check for valid subscribers that are currently live, and it will push that message to them all. A message from a publisher could go into the ether. No one subscribed to it, no one of our other application code actually is interested. Or they were interested, but they've gone out of scope. So it's loosely coupled, and it lets you communicate back and forth between parts of your application, signifying finished download events, signifying other things happening on a server, all sorts of information between different screens or elements. We also created the concept of custom renderers. And unlike the dependency service, I can't talk about this even in 5 minutes. So Jason's talk later in the week, I think it's tomorrow afternoon, will cover this stuff in a lot more detail. But it's like the dependency service, but for the user interface. So rather than just surfacing up the ability to connect to a database or to trigger the text-to-speech service, custom renderers let you build either a new version of our button or a new version of our label, or your own big swath of the screen, like your own user control. And Oxyplot's an example that we've got online of how you can build a custom renderer that's really powerful with just a few lines of code. And this is how we're able to enable the Infogistix and Telerik and other component vendors to partner with us and produce controls. They're producing custom renderers for their own stuff as well. So highly recommend Jason's talk and at the end of the week, or tomorrow afternoon. Further reading. So I have a copy of this book here. You should all have a copy of it, I hope, and if not, you should pick up the one that you're entitled to. It's a preview edition, so there's more to come, of creating the mobile apps with XamarinForms, and it covers a lot more than what we've talked about today. The depth of how XamarinForms works, how to get started, why it exists, and it's got explanation of XAML, of some of the other concepts we've talked about. And Charles was around earlier, he's still around, so if you want to meet the author, he'll be at the back. And he also has 2 talks coming up later in the week, which I would highly recommend as well, because I've only touched a little bit on XAML today, and there's a lot more power to it that Charles will be talking about in his talk. So Loren also has a talk this afternoon that will talk about XamarinForms a bit with MVVM. XAML tomorrow with Charles, extending XamarinForms with Jason, and XamarinForms is way cooler than you think, again with Charles on Friday. So I'd encourage everyone to check those out. And finally, the mini hacks that are happening in the Darwin Lounge upstairs. The XamarinForms mini hack sticker is literally to build the Magic 8-Ball app that you just saw. So that's a gimme for the first sticker, and you only need 6 to get the free battery pack. And finally, another sticker is available if you come running with me in the morning. So that's 2 easy ones if you want to get up a bit early after the Atlanta aquarium party tonight. So it's almost a challenge. But that's it for XamarinForms. I was told to keep this talk somewhere between 45 minutes and 1:15, depending on what happened with the keynote. So I think I'm somewhere in the middle. But there's time for questions. I'm here, Charles is here, if you have any about XamarinForms. Otherwise, I hope you enjoy the rest of the conference. Yo.
In WPF and Silverlight, there's the notion of styles. And I understand that that's not implemented yet for XamarinForms. I was wondering if there's plans for that or what the timeline's going to be.
Absolutely, and soon. Okay. Yeah, you should chat to Jason later in the week if you can collar him, and you'll probably be able to get much more detail on exactly what we're doing. I'm sure he'd be happy to talk about it.
So one of the other talks is completing the Mac app you didn't know you even started.
Mm-hmm.
Do you have plans or thoughts on extending this to Mac and Windows or Windows?
We definitely have thoughts to expand the platforms. We can't really give any timeframes because we're not sure about those. Mac probably isn't the first one we'll go to, but we do want to, it's designed to be extensible. The platform renderer stack that I described sits on top of the UI, can be replicated on other platforms.
Yeah.
So that will come in time.
The slides and the sample code, are they available?
So the sample code for the Magic 8-Ball app isn't because it's a challenge upstairs, but I only had to write 2 lines. The slides, I guess I can tweet those. I'll put them up on SlideShare and tweet them today.
Sure.
Yeah, and the to-do app, that to-do app we walked through is in the Xamarin samples for XamarinForms. So you can find that easily on GitHub, I hope.
On your GitHub?
Yeah.
Okay, sure, thanks.
Is this something that we can use with something like MVM cross or like the UI part?
Yeah, definitely. So you should go to Loren's talk this afternoon because he'll talk about MVVM Lite, but they're similar in nature. But people on the Xamarin forums that are talking about forms, there are people posting there already that have used successfully XamarinForms in conjunction with both of those 2 frameworks. Yeah, there's one coming.
So in WPF and Android, we have a notion of a stack panel, but we don't in iOS.
Yeah.
So what do you translate your stack view in iOS?
So, yeah, please, Charles.
All the layout is handled within XamarinForms. All right, it doesn't go to the platform to do the layout.
Well, we generate it in.
It's right in it's built into XamarinForms.
Yeah, so we don't use the Android stack layout because we want to have a consistent. They don't all behave the same.
Yeah. You'll notice that the stack layout supports this expands option, which turns out to be really handy for allocating vertical space on the screen. That's not in Windows, and I don't think it's in Android either. That was invented by the XamarinForms developers, and it's really nice. It's one of the cool things I talk about on Friday morning.
It looks like. Oh, is there one more question? Yes. So, are you talking about on platform in XAML?
Yes, I will be talking. Yes.
Yeah, you can, and you can find out more on Friday or Thursday.
That'll be Thursday.
Just go to both. Cool. Okay, that looks like it. Thank you very much, everyone, for coming. Oh, one more question. Wait.
I heard that a XamarinForms Android app is a single activity.
Yes, it is.
I'm just curious why you went that way.
I guess Jason would be the best person to ask if you go to his talk. But there's obviously there were reasons why we chose that for getting the platform stack compatible. It solved a few other technical problems. I know fragments is something that is in their minds, but yeah, chat to the designer. Thank you very much, everybody.